Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 21, 2025, just 2 days ago. The standout result is a first-party, full-stack measurement showing the median Gemini Apps text prompt uses 0.24 watt-hours of energy, 0.03 grams of carbon dioxide equivalent, and 0.26 milliliters of water, with a 33 times drop in energy and a 44 times drop in emissions over 1 year. The paper is titled, Measuring the Environmental Impact of Delivering AI at Google Scale, and as we will see later, the scope and rigor are unusually comprehensive. Beyond the headline numbers, the study argues for median-based reporting and shows why narrow measurements can mislead by more than 2 times. Building on that, the tweets highlight the median prompt using 0.24 watt-hours, roughly 9 seconds of TV, 5 drops of water, and massive year-over-year cuts. One post stresses the full-stack methodology across infrastructure. Another cheerfully frames the 33 times energy drop and 44 times emissions cut. Engagement looks solid on the first tweet with around 4,000 likes, signaling strong interest. Alright, we are looking at a comparison chart that contrasts earlier measurement boundaries with a comprehensive approach covering chip power, utilization, host CPU and memory, idle machines, and data center overhead. You can see the top grid lists prior studies that mostly measure accelerator chip power, while CPU and memory, idle capacity, and overhead are often omitted. The bottom bar introduces the full stack view, which adds production utilization, host energy, provisioned idle machines, and actual campus power usage effectiveness. The shift matters because including these layers raises per prompt energy substantially and guides better optimization. Now we are looking at a scatter and bar style chart that maps model quality against prompts per kilowatt hour, so larger values mean lower energy per prompt. You can see the long blue bar at the top right for median Gemini, which shows far higher prompts per kilowatt hour under the existing approach than under the comprehensive one. The green cluster for GPT-4o sits around 1300 arena score with mid-range energy efficiency. The red llama points span a wide energy range, illustrating how measurement boundaries can swing results dramatically. Now we are looking at a stacked bar that breaks down energy per prompt across the serving stack. You can see the largest block on the left labeled Active AI Accelerators at 58%, which shows most energy sits on the chips. The next light blue segment marked CPU and DRAM contributes 24%. Then the 2 smaller blue blocks on the right add 10% for idle machines and 8% for data center overhead. Together, these pieces explain why the comprehensive total is higher than chip-only views. Now we are looking at a table that contrasts the existing approach with the comprehensive approach for median Gemini text prompts. The table shows 0.10 watt-hours when counting only accelerator power in the most efficient data centers, while the fuller boundary adds CPU and memory at 0.06, idle machines at 0.02, and overhead at 0.02, which lifts the total to 0.24 watt-hours. You can see that the key difference is scope, so the broader accounting more than doubles the per-prompt energy. This table neatly ties the breakdown to the headline total. Now we are looking at a 2-panel figure that tracks emissions per prompt from May 2024 to May 2025. The upper panel shows market-based Scope 2 dropping from about 1.07 grams to 0.02 grams, with callouts that attribute gains to model efficiencies, better machine utilization, and clean energy procurement. The lower panel shows Scope 1 plus 3 falling from 0.36 grams to about 0.01 grams. Together, these declines combine to roughly a 44 times reduction overall. Now we are looking at a summary table that compares the existing and the comprehensive accounting for a median Gemini text prompt. The full table shows energy rising from 0.10 watt-hours to 0.24 because host energy, idle capacity, and overhead are included. You can see emissions shift from 0.02 to 0.03 grams, with Scope 2 market-based and Scope 1 plus 3 listed separately. Finally, water increases from 0.12 to 0.26 milliliters, which reflects the broader boundary. Building on that, 2 takeaways stand out. First, measurement boundaries matter because counting host energy, idle capacity, and data center overhead roughly doubles per prompt energy versus chip-only views. Second, real production improvements can be massive, with a 33 times energy drop and a 44 times emissions drop in 1 year. Power usage effectiveness describes facility overhead, and market-based emissions use purchased clean electricity data. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.